All right, let's simplify this expression. You sometimes get expressions like this when you are using the quadratic formula. So let's see. The first thing we need to do is we want to simplify this radical, because when you see a radical and it's not in its lowest terms, you definitely want to simplify it. So I'm going to go ahead and split it up. I'm looking for factors of 150 that are perfect squares. So let's see. Um, Factors of 150, or let's just look at specifically perfect squares. So perfect squares that go into 150, let me see. Well, let's start with 100. 100 is too big. Um, 81 also a bit large to go into 150. So there's 64 doesn't go in. Um, Let me see. 49 doesn't go in. Um, 36 doesn't go in. But 25 does. I think we found a winner. 25, the largest perfect square, there's going to be a factor there. So I'm going to break that up into the square root of 25 times 6, because 25 times 6 would give me 150 if I multiply them. So 25 times 6. And this is still divided by 45. And then I'm going to break that up into two radicals. So it's going to be the square root of 25 times the square root of 6 all over 45. And we know what the square root of 25 is. The square root of 25 is 5. So that's negative 40 minus 5 square roots of 6 over 45. And now we can try to simplify this fraction. Now, when you simplify a fraction, you want to make sure that you're not canceling terms. You're not canceling things that are being added and subtracted, like these are being subtracted from each other, right? So we want to make sure that we're only canceling common factors. And in order to see what the common factors are, you have to factor any binomials or trinomial factors, or parts of the fraction, like the numerator here is a binomial. So we want to factor that. We want to factor out the factor of 4. There's a monomial, or not 4, sorry, 5. There's a monomial factor of 5 in both of these terms. This is 5 times 8. This is 5 times the square root of 6. So I can factor that 5 out, leaving the first term as only the negative 8 that you multiply by 5 to get 40. And the second term would be the negative square root of 6 that you'd multiply by 5 to get negative 5 square roots of 6. And that's all divided by 45. Now that I see that there's a factor of 5 on top and a factor of negative 8 minus the square root of 6, which probably doesn't occur on the bottom, I know that I'm probably trying to cancel out this monomial factor of 5 with any monomial factor of 5 in the number 45. And it turns out there is a factor of 5 in 45, because 45 is 5 times 9. So therefore, the factor of 5 I can divide out at the top, leaving just negative 8 minus the square root of 6. And the factor of 5 I can divide out at the bottom, 45 divided by 5 is 9. So the answer for this would be negative 8 minus the square root of 6 over 9.